Now question 9, section A. State the name of the logic gates with the symbol shown in figure 9.1. Students must be familiar to these schematic diagrams. So this one is NAND. Okay. NAND, this is only AND, and this AND, the circle here for the NOT, so they combine together, we name them NAND as one logic gate. And for B, state the name of the logic gates with the truth table shown in table 9.1. Now the examiner is asking if the input is 0 and the output is 1, and the input now changes to 1 and it becomes 0. So the function of the logic gates now is to invert the input and you get a different output. So if it is 0, 1 and 1 and 0, on and off, off and on. So there is only one logic gate, has only one input and one output, which is the NOT gate. Part C, figure 9.2 shows a digital circuit. Complete the truth table in table 9.2 for the circuit for all possible combination of input. Table 9.2. According to the diagram, we have two inputs, A and B, for both OR gate and AND gate, and the C, which is the output for the OR gate, and the D, which is the output for the AND, and the C and D represent as input for the NOR to the NAND, sorry, and this is E, which is the output. Okay, we have 4 marks, so please take care while doing the calculation. For C, he said it's 1, so I'm going to circle this one, and the D is 1 as well. Okay, I will write C1 and the D 1. Okay, the option that give us C as 1, so it's okay, A and B, they are going to be 1, 0, 0 and 1, or 1 and 1. But the issue is the problem with AND. In AND, to get 1, so A and B must be 1 and 1. So, okay, so I've been forced to make A and B, they are 1 and 1. Okay, so I will write A, they are 1 and 1. For case 2, C is 1 and D is 0. So I would write 1 here, and for D is 0. Okay. So C at 1, it means that no problem if the A is 1 or the B is 1, so no problem, 1 or 0, as I said before. But D, it means 0. It means that one of them is going to be 0, no problem. And if they are 0 and 0, it works, but we have to make sure that the output for the OR is going to be 1. So one of A and B must be 1, and the other one, it's okay if it is 0. So I would say the A is 1 and the B is 0. Case 3, C and D, 1 and 0. So go quickly. The 1 here and the D is 0. So as I did before, so I'm going to switch to make it 0 and 1. No problem. Here it's 0 and 1. So I would write 0 and 1. Okay. Finally, the last one, 0 and 0. Okay, so I would write 0 and 0. It means that both of them, they are going to be zeros. Okay. The C and D, they are the inputs for the NAND, and the E, which is the output. So we have the 1 and 1, and 1 and 0, and 1 and 0, and 0 and 0. For case 1, if we have 1 and 1, for AND, it gives us 1, but we have not here, because the whole circuit, or the whole, this schematic diagram, which is NAND, so it's inverted into 0. And if we have 1 and 0 for the AND, it gives us 0, but we have not, as I said, so it gives us 1. So it is inverted. If it is 1 and 0, it gives us 1. It give us 0, but it is inverted by the not give us 1 again. 0 and 0, it's 0, give us 1.